Hi, my name is Josh Benson, and we're going to be looking at a ratio problem. The basic layout of the problem is this. Luis and Maria are comparing the amount of money that they had in their pockets. Maria's amount of money is 4/5 of Luis's amount of money. So wherever we go from here, let's first just graphically lay out what we're actually saying here is that Maria has 4/5 of the amount of money that Luis has. So 1, 2, 3, 4. 1, 2, 3, 5. So just as a quick little graphic representation, for every 4 units that Maria has, Luis has 5. So we come to the first aspect here is the A part of the question. What is the amount of money that Luis has in his pocket compared to Maria? So we don't have any solid values yet. We're not saying exactly how many dollars or pounds or euros are in their pockets. We're just trying to establish the ratio. If we want to say how much money Luis has compared to Maria, we have to flip them around on the fraction. And we're now saying that Luis has 5 for every 4 Marias. So we have to switch this back up. So we're still saying that we have the same 9 parts, but we're establishing that the ratio in relationship to what Luis has. Okay, so we have the same problem, and again, we don't have a definite amount of money that each of them has. We don't have how much there is altogether. We just want to know a couple of different solutions for this. So again, if we say that Maria has 4 and that Luis has 5 for every 4 that Maria has, there's a couple of different ways to look at this. And one is that the ratio will hold if you multiply this out by anything, as long as you multiply it to both sides of the equation. So one way we can look at that is if we just double up. So let's just say the multiplier was 2. So what we'd be seeing is that Maria would have 8 for every 10 that Luis has. And you could go on and on with this. You could do it, you could put 3 in each layer, and then you would have 12 and 15. So on and so forth. You could do this. You could make each one of these squares. You can, instead of doing this by putting extra squares on top, you could change the value of each individual square. You could say that each square is itself a $20 bill. So each square represents a $20 bill, in which case Maria would have $20, $40, $60, $80, and Luis would have $20, $40, $60, $80, $100. So once you've established the ratio, really you could expand that up by any multiplier. Alright, now we have part 3 of this problem. Now we have a known value. We're looking to find $45 out there. We still have the same information from before. We know for a fact that Maria has 4 of these units, and that Luis is in ratio to her at a 4-to-5 ratio. So what we have to do at this point is we have to look at how many total parts there are. So at this point, it doesn't matter whose they are. We'll just have to count all these parts out. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 total parts. So if you have $45 and there are 9 equal units within that $45, we know that that's 45 divided by 9. That would make each one of these individual units worth $5. So the easiest way to graphically represent this with what we already have out on the table is you just make one square worth $5. You could even just kind of represent, you could say each one of these squares is a $5 bill. So if that was true, then Maria would have 4 of these $5 bills, and 5, 10, 15, 20. So that would mean that Maria specifically has $20. And Luis, he would have 5 of these $5 bills. So he would have 5, 10, 15, 20, 5, $25. And then if you add those back together, just as a double check or cross check, you will see that $25 plus $20 is in fact also $45. So given the ratio, given the addition of all parts of the ratio to find out how many parts there are, and then dividing that by the known value, you can find out how much each one of these people has in their pocket. Anyway, I hope everybody enjoys the video, and we'll see you in class. Okay, bye for now.